Hello, and welcome to Chapter 2. And today is going to be an exciting day because we are get into the switch itself, and we're going to learn how to create a management VLAN so you can remotely access the VLAN either with Telnet or SSH. We are going to secure also the ports on the switches. We'll learn a little bit about the switches itself. So we're going to really get into the switch and understand how the switch operate and have how to manage it and secure it as well. All right. So watch out for the questions that I'm going to ask. Well, here's what the questions are going to be. All right. Everything that I do in Packet Tracer, I want you to can do it. And then when you are done with it, you save that packet tracer file that I'm going to do in here, and you submit that as homework. Is that clear? So you submit the packet tracer. I want you to do whatever I do in the packet tracer, show you as exercises on how to, for example, create a management VLAN, how to use SSH, and how to secure the ports on the switch, and then submit that as the homework as we go along. Okay, and don't forget chapter 1's homework too. You answer those questions that I asked in Microsoft Word. So for week 1, homework is the questions from chapter 1, and for week 2, it's going to be this. I'm sorry. For chapter 2, is going to be the packet tracer file that we go through. All right, so pay attention and try to understand how switch operate, because everything that we do this semester in terms of switching is going to be based on the switch, right? How to do the basic configuration of it and how to manage it. All right, so when you turn on the switch, the first thing that happened is the post execute. A post is a program that is located on a ROM memory chip on the motherboard. As soon as you turn the power on, it gets excited and bingo, it goes up and it runs several diagnostic programs that is going to test the hardware of your switch, just like the router post. And once everything, you see all the LEDs, the system LEDs and all the other LEDs in front of the switch are blinking green. That means that the post is running. If it turns amber color, the orange color, you know something is wrong, and therefore your switch is going to freeze, and then you have to troubleshoot what hardware is really bad. But in most cases, the post will be successful, and that LED will turn solid green. Then the bootloader will kick in. Bootloader performs low-level CPU initialization. It's also going to make sure initialize the flash system so that you can go and grab the operating system. This is similar to the bootstrap. Then the bootloader is going to go and get the operating system, and most likely he is going to get it from the flash. That's why he needs to initialize the flash. Now, once the operating system is loaded in the flash, then the internetworking operating system takes over. Okay? So, to find the suitable, where do I go and find that operating system, the bootloader? Where does he go to look for? First, he is going to check Bootstrap. He attempts automatically to boot using the information in the boot environment. This is really the configuration register, which we'll discuss some other time. Now, if the variable is not set, then he goes from top to bottom. He goes to the flash, because that's really where the full image of the operating system is located, and hopefully finds it there. Now, if it doesn't find it there, you may have it on an FTP server, TFTP server. And if it's not there, you'll go into the ROM monitor, which is where you want to be, which is where you don't want to be. That means there is no operating system in the flash, or the operating system in the flash is corrupted and it did not load correctly. Now, assume that it finds it and it loads it correctly, then the operating system takes over, and then the operating system goes to the NVRAM to see if there's a startup configuration file is in there, and grabs it and loads it into RAM so it can execute it. If there is no startup config in the non-volatile RAM, then you have to create one, right? This is just like a router. If you don't have a configuration file, the switch is not going to operate the switch. It's going to have problems. All right. You can always type boot system command if you want to boot, boot system with a different operating. Let's say you have multiple operating systems inside the flash. You can say boot system and the name of the flash colon and the name of the operating system that you want the switch to boot up, and you could do that, on the spot at any time. Now, what happened if your switch crashes for whatever reason? You have a bad operating system and it did not load correctly, or there is no operating system in the flash. So what do? You take your PC, you connect to the console port of the switch, right? Turn off the power, which actually there is no switch for the those Ethernet switches. There is no power switch. You have to unplug the cord from the wall and then plug it back in, and when you plug it in, make sure you press the mode button and keep holding on to the button while it's loading up. The system LED, while you're still holding, wait till the system LED turns green. It briefly goes amber, then it turns green. Once it turns green, you let go with the mode button, and then you'll be at the switch prompt where you can type in commands to fix your, reload a new operating system into the switch. All right, so this is a quick way of easy. By the way, it's a different procedure to recover a system crash for a router than you would do for a switch. So these are the steps that you would do for a switch. And remember they ask you these questions on a CCNA exam or your CCNT exam. So look for that. Okay, here are the different LED indicators that you'll see in front of the switch. The system LED, this is just for running, make sure that the system is running correctly, loading, during loading up of the post and the power on self test. And during bootstrap loading up the iOS, the LED will be blinking green. If it turns color, that means the boot up, something is wrong with the boot up. The redundant power system, you want to make sure if they are redundant devices in your switch, backup devices, you want that to be green. That means they are active and they are backing up your data, or a mirror image of the devices that are in there. Port status, it tells you if the port is, if it's green or bringing green, that means it's accepting data on top of those patch cables that you have. I'll show you in a few minutes. If it's amber, that means it's blocking data. If it's dead, then you don't see any light. That means you have bad connection. Something is wrong, or it's not being configured. The duplex mode, it tells you if you are full duplex or half duplex. Speed mode, it all tells you what kind of speed that you are operating at. Power over Ethernet, to tell you if there is power over Ethernet connection on your LEDs. And here they are. You can check them out all right here, right? And these are the port status. So when you plug in a cable right here onto the switch, and this should turn green, because when it's communicating to the PC, if it turns amber, then you got issues, of course. Okay, here is the mode button that you hold when you plug in the cord onto the switch and you're trying to recover your switch from a crash. All right, let's talk about the basic switch management. Managing a switch, meaning you want to be able to configure the switch and type in, being able to get into the switch, get into the user mode, the config mode, without having to be physically right next to it using a console port. All right. So, although you should never give a switch an IP address unless you want to remotely access it. And what you do is you have to give the IP address to a switch virtual interface, which is really a VLAN. Okay. The switch by itself has its own VLAN, VLAN 1. So here's how we're going to manage a switch, and we'll talk about that in a second. Let's get back. Let's go to Packet Tracer. So here's what you're going to do. Open up a Packet Tracer, grab a 2960 switch, put it right here. Okay, and what we're going to do is, we are going to also put a router, put a 2811 router. Okay, and let's get two PCs. Let's get two genetic PCs, one on this side and one on the other side. And let's connect them. Let's get this guy to fast Ethernet 0.1 to 0.1, 0.2 to, let's say, 00, and a crossover from 001 to 0.2. These are two different LANs. So let's put this switch on to, let's say, 192.168.10.1, same slash, and let's put this PC on 192.168.10. Not dot 10, dot 11.1. Okay. This is going to be 11.2, and this is going to be 10.2, right? The default gateway. By the way, what did I do? Now I want to get into the router and configure the router. You know, I usually go in here and go to the CLI. This is really doing the console port, but let me just go over using the console. And I'm going to use PC1 to console into the router. So I click on PC1, go to RS-232. So I'm going right next to the router itself to configure it. So I'll click here and go to console. I want to go in there and connect to the router itself. So I'll click on the desktop. I go to terminal, say OK, and I'll say no, and I'll go into the router and I'll type en config t. Let's give it a host name of R1 and no IP domain lookup. This is to disable the DNS lookup, right? Remember that? Now, let me go to interface fast Ethernet 0/0. That's going to be the default gateway of this PC, PC1, right? So he is going to be IP at 192.168.10.2, we said, right? With a mask of 255, 255, 255.0. Activate it by typing no shut, and then go to interface fast Ethernet 0/1, which is this guy right here. And I'm going to say IP at 192.168.11.2. That's too many ones. .11.2. 55, 255, 255.0. And then type no shut on that. Okay, so now I can go back to the PCs, and now that they have a default gateway, put in their default gateway down here. 192.168.10. I'm sorry, not .10, .11. Not, of course, .10.2. What am I talking about? All right, it's this PC that gets the .11, right? And I go in and I say 192.168.11.2. So that's his default gateway, which is this guy right here. Okay. Now, once you configure the router, you're pretty good. Now, what we need to do, we have to be able to telnet to remotely access the router. Well, we don't have to remotely access the router. Okay, what we really need to do is, hold on a second, I got to turn off my son's playing games here. Okay, here we go. So what we need to do is we need to be able to tell, we just configured the router itself. So I can now remove this console port and put it on the switch and go on the switch's console port, right? And then I go to PC1, go to terminal again, and now I'm on the switch. Now, to remotely access the switch, what you need to do is the following. First of all, let me type en config t, and let's call it host name SW1, right? And then type no IP domain lookup on the switch. Okay, do end, and then I want you to type show VLAN. This is a switch virtual interface, VLAN 1, right? And it has 24 fast Ethernet port and 2 gigaports on this switch. And there are 4 additional VLANs, 102, 1002, 3, 4, and 5. So if anyone ever asks you how many VLANs are created by default on a 2960 switch, the answer is 5, right? So now, if you are going to give an IP address to the SVI, the Switch Virtual Interface VLAN 1, that means anybody that is attached, attached to any of these ports will be able to get into the switch and manage it. But typically we don't want to do that. So what we want to do is we want to create a separate LAN and just put the port, let's say Fast Ethernet 01, because PC1 is the manager, and put Fast Ethernet 01 in that VLAN. So it's like creating another switch inside this physical switch, and that will be I will assign that to the VLAN, to the management VLAN. So what is a VLAN? A VLAN is really a logical switch, a software switch inside this switch. And this is how you create a VLAN. We're going to learn that next week, but next chapter. But here's what you do. Do config T, and you say, let's say VLAN, and the practice is to create the management VLAN, we give it a VLAN 99. So type VLAN 99. Hit enter. Okay, just type exit. That's it. The VLAN is created. Okay, then what you're going to do is you're going to say, and first of all, then we're going to go to interface fast Ethernet 0/1 and move that fast Ethernet 0/1 from VLAN 1. We're going to move it to VLAN 99. So hit enter after you type interface fast Ethernet 01. Type switch port mode access. Now this command tells fast Ethernet 01 that you are going to be a data port, which means a PC is going to be attached to this port. Now the port can be, by default, the port is dynamic, which means it can act as access, it can act as trunk, it can act for voice over IP, but you specifically want to say switch port mode access. And by the way, you can only set security on an access port. You can't do it on a dynamic port. So if you leave it dynamic and you don't want this command, you are not going to be able to set port security on it. So you have to do that. That's also another question that comes up on a CCNA test. Okay. Now, once you made the port an access port, then you say switch port. It's one word. Switch port access. Okay, I gotta make sure I'm spelling these right. Switch port access space VLAN 99. So now that port 01 has moved to VLAN 99. Press the control key and hit the letter Z, or type exit, either way. Exit twice and hit enter. Then type show VLAN, SH VLAN, hit enter. You see now we have a VLAN 99, another switch, and it has one port in it, which is this port. Okay. All right, now, so that's in VLAN 99, and let me show you. Now we want to be able to telnet into the switch. So I'm going to go config T. I'm going to create the VLAN 99. I'm going to say interface VLAN 99. That's going to be my management VLAN. It goes up, so you don't even have to type no shut, although it is recommended that you do that. Let me give it an IP address. IP add 192.168.10. Now, this has got .1, this got .2, this is going to be .3, right? So give it .3, right? With the that mask 255, 255, 255.0. Okay, and then you type no shut, just for the fun of it. Now Control Z. Now to enable telnetting, you are going to say line you've got to be in config mode. Config T. You're going to say line VTY 0 to 15 for the switch, right? And you're going to set up a password, Cisco, and you're going to say login. And you are going to do the enable secret Let's call it Cisco 1 to get into the privilege mode. That's it. Now PC1 will be able to telnet into the switch. Now, what about PC2? Will he be able to telnet into the switch? Well, let's test this out. Let me show you, and we'll explain. Let me minimize this. Let me take out the console port because we no longer need it. Okay, now I can go to PC1 and I go to here and I'm going to type telnet space 192.168.10.3, right? And the password to get it, now I'm telnetting into the switch and the password is Cisco. So I'm inside the switch. You see SWN as the host. Now I type enable and Cisco 1 and then I'm all good. See, I can type show VLAN and I can do show run. I can access it. Now, here's the IP address of VLAN 99. Now, can PC2 get in the switch? Let me see. I type telnet and the IP address of the switch, now which is VLAN 99, 192.168.10.3, right? Now, can I get in? Although the switch should allow me to get in. And the problem is because the switch doesn't have a default gateway to send the data back to him. So we should give the switch, even though we did give it an IP address, but if you are outside your LAN trying to get in, you have to go back to the router, but this guy doesn't have a default gateway to come back in. You understand? PC1 was able to get in because he didn't have to go through the router, right? He was able to tell it. But PC2, he was able to get there, but cannot come back because the switch did not have a default gateway. So let's go back to the switch. I'm going to go to the CLI. And at the config mode, you type IP space DEF and hit the tab key, default gateway, and the default gateway on that side is 192.168.10.2. Okay, now once that's been configured, PC2 should be able to telnet into the switch. So I'll go back to PC2, hit the upper arrow key again, and hit enter. And it should be able to let me in. Let's see if that happens. Nope, it did not let me in. Oh, I see, because this guy is not in VLAN 99. He should be in the same no, he should be able to. Something is not correct here. Let me see, is it .192.168.10.2 is the default gateway? Let's do a little bit of troubleshooting. Hold on a second. Control Z, show run. And I see that VS Ethernet is in 0.1. Okay. 192.168.10.3. Okay, good. That's good. Let me see the router interfaces. I type enable, show run, and see fast Ethernet 0.0 is 192.168.10.2. Fast Ethernet 0.1 is 192.168.11.2. Good. Well, let's go to PC2 and make sure that he has a default gateway. Everything's good. Yes. Let me ping 192.168.10.11.2. That's his default gateway. Good. It responds. Let me ping 10.2. That's the default gateway of the other side. That responds. Let me ping PC1, which is .1. Okay, he's in a different LAN. Now he's not pinging PC1. He's timing out. PC1 is not, I cannot ping PC1 from here because he's not in VLAN 1, I say, because we placed him on a different VLAN. Okay, but if we have a, okay, now I understand. Now if we have a switch right here and he has to be in the same subnet as the other guy to be able to manage the switch, to remotely access it. So this one actually, oh, I see. There's no trunking. That's my mistake. That's what it is. All right, we'll talk about that next week. There should be some trunking protocol that allows you to tag the frame before it gets to here. So this will be a trunk, and we are going to, we can actually set this as a trunk. You know what? Should we do that? We go to this port right here and tell it it's a trunk. And here. I'm going to do this, although we're going to talk about it next week. I'm going to make fast Ethernet 02 a trunk, config T FA0/2, and I'm going to say switch port mode trunk. Now he's a trunk because there are two VLANs here, right? One VLAN 1 and one VLAN 2 on 02. Okay. And then I have to go to the router fast Ethernet 0 and make some sub interfaces. Oh, wow. You know what? We can do that by going, let's go to the, let me see if that works. Let me go to the router. We do config T, and I go to interface fast Ethernet 0/0. I do encapsulation. No, it's not going to work that way. Oh, God. Type no IP add. I'm sorry, go to interface fast Ethernet 0/1, 0/0, right? And type no IP add. Type no shut. It's active. Then type interface fast Ethernet 0/0.99. And then say encapsulation DOT1Q 99, and then give it the IP add 192.168.10.2 with 255.255.255.0, and say, you can say no shut if you want to. Okay, that should do it. Let's see if this now can ping. Can telnet into 10.1. If not, we have to create another one. Yeah, with timing, this still doesn't work. All right. You know what we'll do? Let me just bring it back the way it was then. Okay, Control Z. And then what you do is you say config T interface FA0/0. FA0/0. Oh God. 0/0. Type no shut. Well, actually, you know what? Leave it. We don't need this. So let me see. Just show run. And fast Ethernet 00 doesn't have an address. We can type shutdown on 0.99. That's all. So type interface FA0/0.99, and oh God, we got to do config T first. Config T. Type interface 0/0.99. What am I doing? FA0/0.99, and type shutdown. Here you go. The interface is shut down. I can type an exit now. I can type and that's it. Okay. So just leave that alone. Okay, so now let's continue. So we can only manage telnetting. We'll talk about that later on next week when we actually we don't need a router between them. And this is really a packet tracer issue to create a sub interface. I wanted to see if you can resolve that problem quickly, but it's a little bit more involved in there. But we'll talk about that next week when we get into VLANs. All right, but this is how you set up telnetting into a switch. All right, so getting back into the slides. Now, the ports on the switch can be set up either full duplex or half duplex communications. So full duplex means that the switch is able to send and receive data at the same time. Half duplex meaning it's either I send or receive, but I can't do both. All right, so it's preferable that you have the port set up as full duplex, but they always set at auto, which means automatically negotiate what the other side is, and therefore they'll set themselves depending on what the other port is set up as. If it's set up as half duplex, the other guy will set up as half duplex. If it's set up as full duplex, it will set up as full duplex. If you want a port to be full duplex, both of them, then you go right here and say interface fast Ethernet 0, excuse me, duplex full. And I want the speed to be 100 megabits per second. So that means there's no negotiation. And this guy will set himself immediately. You should also set this side the same way. You know, duplex full, speed 100. And make sure you copy the running configuration to the startup when you're done. Now there's the Auto-MDIX feature, which, you know, the medium dependent interface crossover cable, which means as long as you have the interface speed on the switch set to auto, that means you should have a crossover cable here. But because the ports are set up to automatically negotiate, the MDIX feature, what it does, it says, yeah, you're straight through. Okay, you don't have to change the cable to crossover because they are the same type of, you know, similar devices. You should use a crossover. What the switch does, it will configure himself to make sure that the data that is being sent on pins 1 and 2 is received on pin 3 and 6, for example. So you don't have to worry about changing cables. You can choose either a crossover or a straight through. The MDIX will take care of the rest. Okay, and this is how make sure that on each port, duplex is auto, speed is auto, and MDIX is auto, and that means you can use any type of cable that you want. All right, you can actually check that out by looking at the show controllers Ethernet controller FA0/0, right? So type show controllers, show me the Ethernet controller FA01 at the physical interface, and when you do the bar include auto-MDIX, that means you only want to see the MDIX and how it's configured on this interface, and you'll see that it's on. Here are some verification commands on the ports on the switches. Show interfaces if you want to see fast Ethernet 01, 02, and any interface that you want. If you want to look at the status of the interface, if it's on or off, if it's been configured correctly. Show startup config or show running config will do that. Show flash, you take a look at what's in the flash memory. Show version tells you the version. Show history, all the commands that you have typed. That's when you hit the upper arrow key. It always allows you to pick up, allows you to repeat the commands that's been done in the history. Show IP and FA00 or IP VLAN 1. It'll give you the IP address. Show MAC address table displays the MAC address table like we did from chapter 1. Here's a typical command. When you type show interfaces, fast Ethernet 01, it's going to show you the runs. The runs are called sometimes fragments, anything that are less than 64 bytes. There's no bad frames less than 64, and there is no huge frames, giants, right? It gives you a whole bunch of other errors. You know, runs are fragments. Anything that less than 64 is called a runt. So that switch did not recognize any runs. No giant frames, nothing larger than 15, 18, because remember, the largest frame size, Ethernet frame size it can be is really just 1518, right? Input errors, CRC check, output errors. You can check all of that, all right, when you type that show interface. Now, troubleshooting a switch media, the cable, the interface itself. So when you type show interfaces, if you see two ups, if it's yes, make sure that means that everything is good. Yeah, let's say you're having a problem and you type show interfaces, you say protocol up and the device itself, the port, no, the port is up too. If that is a yes, then what you do is you make sure that there is no electromagnetic interference that's causing some of the problems. Check out the duplex mode, make sure they're both the same on both sides. And if everything is fixed right here, and the problem should be solved. Now, if you see that the interfaces are not both up, you're going to check out, make sure that the cable is plugged in correctly. The cables are, you're using the right cable. If MDIX is not active, verify the speed, the configuration, right? IP addressing, if there is such a thing. If it's, well, actually not an IP address because you're not connected. Unless you're not connected to the router, you're connected to the switches. Okay, so it's really a problem issue when you connect to a switch. The SSH. Now, when we telnet it into that switch, we were able to telnet, but all the information that was being passed was in clear text, so we could not be able to telnet. You should not be able to telnet into the switch. So what you should do is you should always use SSH. SSH will always allow you to type in, get into the switch, and all the data is being transferred between the PC and the switch are going to be in clear text. All right, so we are going to set up an SSH. So let's go back to Packet Tracer. Here's what we're going to do in Packet Tracer. What I want you to do is I want you to remove PC2, and you know what? Move the router. We don't need it either. All right, let's plug in a PC, bring in another PC, PC3, put that PC3 on port 02, right? And give PC 192.168.10. Well, remember, this is .1. He's going to be .2. We removed the router, so we don't even need it. Okay? Close that. Now we got to make sure that this port is in VLAN 99 because VLAN 99 is the one that got the IP address. So let's repeat and move this port to VLAN 99. So type EN. What's the password? Cisco. Oops, is it Cisco? Cisco. Oh, no, Cisco 1. That's what it was. Config T, right? And let's go and type interface fast Ethernet 0/2 and say switch port mode access. And then do switch port access to VLAN 99. So now both of these guys can telnet into the switch because they're both on the same LAN, and so the switch VLAN 99, right? Anybody else in any other port will not be able to telnet because they have to be in the same local area network, and VLAN 99 is the correct one. All right, now how do you set up SSH? So what I'm going to do is first, you want to see if he can telnet. We got to wait till it turns green. So I'll just go to here and I can type telnet. The switch, if you remember, the VLAN 99 is 192.168.10.3, right? And the password is Cisco. And I was able to get in, right? And then you can type enable and type the password is Cisco 1. And now I'm in the switch. And if you type show VLAN, and you can see that VLAN 99 have 02 is on that switch. But what happened to 01? 01 is not in there? Whoa, what happened? Did I oh, we must Okay, let's do config T. Let's go to interface fast Ethernet 0/1 and say switch port mode access and switch port access to VLAN 99. That's probably what was the problem before. Let me do Control Z and type show VLAN. And now both of them are in the same VLAN, and now both should be able to telnet into the switch. But what you should do is you should remove telnetting. Here's what you would do. Close this. Now let's go from PC1 and use the console port. Go to RS-232. Let's assume that we want to set it up through the console port first. Okay, click on the PC, close this. We don't want to telnet into the switch. I want to remove telnetting and I want to use SSH instead. So I'll go to the terminal. Okay, and I'll do line VTY 0 to 15 for a switch and say no password and say login. Okay, you disabled it. So now nobody is able to type in a password through the switch itself. Okay. In fact, what you could do also, okay, anyway. Now, let's say if we can do, let me, here, get back in here. Oops. Now let's get back. Now here's how you do SSH. The first, type exit, make sure you are at the config mode. Okay, and the first thing you're going to do, you're going to say IP, domain name, IP, domain dash name, and let's say devry.edu. You have to create a domain name. You have no other choice. That's how it works. You have to be in a domain to do SSH. And then you're going to create a key. Type cryptos, type CRY, and hit the tab key. Write the word key, space, generate, GEN, and hit the tab key. Generate RSA. So that is going to create, now they're asking you, do you want a 512 byte key? What it's going to do is going to generate two keys. One is going to be called a public key, the one that you send out to the PC. Whenever they want to send you information, you will encrypt the data with it. And the other one is going to be private, which one you keep. And nobody is going to be able to see it. The bigger the key, the more bits, the better. So the default is it's asking you, do you want that key to be 512 bits? If you hit enter, you say yes. Now for, let's say I want 1024 key. I want to make it a little bit bigger. Okay, so it generated one. Now, if you do it on a real switch, it's going to take like 5 minutes to generate a 1024 key. Okay, now that the key is generated, now we're going to say a username. And let's say you're going to create a username, call it admin. And he's going to have a password called Cisco. Now, from now on, that's what you're going to do to get in. They're going to ask you what's your username, and your password is Cisco. You're not going to do line VTY. Now, that's it. Then you're going to go to line VTY, 0 to 215, and you're going to say transport input SSH. Now, what that means, you are only allowed to go into the switch using SSH. You cannot use Telnet anymore. And then you're going to say, when that comes in, login local, which means when they type in their name, admin, and the password Cisco, verify them locally. Don't go to, let's say, another server, which we'll talk about in CCNA security to authenticate the username and the password. All right, so once you type that in, then you are good to go, and just type ent. Okay. Now, what we did is the following. We created two keys actually using RSA, 1024-bit keys. One key will be kept, and the other key is going to be given out to anybody that wants to SSH into the switch. That's called the public key. Now, the two keys are related. If you encrypt the data with one key, the only person that can decrypt it is the switch because he has the private key. If PC3, for example, he was an intruder and he sees that key, he cannot decrypt the data with it because you cannot decrypt the data with the same key. If you encrypt the data with one key, you have to use the other key to decrypt it. And the other key, the private key, is there and you cannot touch it. Let's take a look at the public key because anybody can have it. So type show crypto crypto key RSA. Oops. Well, actually, crypto key my public key RSA. And there's your key. Look how big it is. So all of these numbers are in hexadecimal. That's your key. But you cannot see the private key. You can't even, there's no command to actually see it anyway. Okay? So now that SSH is running, we no longer need this cable. Okay, now I can go to PC1, and here's the command how you can actually close this. And let me get back in here. And now I type SSH minus the letter L, and you want to go in with the username admin, and the IP address of the switch is 192.168.10.3, right? Now, here we go. He says, okay, I went in. I got the word admin. Now give me the password. And what is the password? Cisco. What was it? Cisco? Just Cisco, right? And bingo, I'm in. I can type exit. Well, I can type enable. And the password is Cisco 1. And now I can do show VLAN. Okay. If you type exit, if you try to do SSH, let's say you type, if you try to do telnet into 192.168.10. What is it? .2. The switch got .2, right? And you can't get in. Why? Because telnet is not allowed. Only SSH now. All right. So now you learned how to set up SSH. Leave that alone. Let's continue. So this is what we actually did, right? Those are the steps. Make sure you copy this down. This is also very important, and you will be asked on this, I guarantee you, on a CCNA, how do you set up SSH? Okay. Usually you can actually do SSH directly from packet tracer on the PCs using PuTTY. We'll do that in class. All right, so you can type show SSH, shows you that version 2. We did the 1024 bits, right? All right. Now, here are some security issues with the switch. Switch can automatically, switches automatically populate the CAM like we talked before by inspecting the incoming frames, the MAC addresses that are stamped on the source, and he knows which port they're coming from, and I can populate them. So an attacker could exploit this behavior. And normally it's controlled by the PC. Somebody can send a whole bunch of bogus numbers, MAC addresses on the PC, right? And when that happens, if let's say the switch has all the appropriate MAC addresses, he knows where everybody is located. But if an attacker comes in and change all these MAC addresses, so when a frame comes into the switch, and the switch looks up the destination MAC address and he looks at the chart, he doesn't see it because the attacker changed them all. So what does the switch do when he does not find the destination MAC address? in the MAC address table, he floods the ports. He sends the data to all the ports. So what that actually does is changes the switch into a hub, because that's what a hub does. When it receives a frame, it floods all the ports. So we got to be careful when we are doing that. All right, it can turn the switch into a hub, and therefore you want to make sure that you can control who has access and who does not have access. All right. So an attacker comes in and he says, all right, a bogus address is altered for number 3. He can change his MAC address, instead of, he puts in a Y. And now data, when I look it up, it says, oh, MAC address Y, send them to port 3. So all the data will be coming to port 3, for example. He can go in and say, everybody come to port 3, no matter who your MAC address is. So the attacker can grab all the data, right? If they can get in and change what ports the data should be go to, or he can change the MAC addresses, right? So either way, it's really an attack to the switches, and we don't want that. We don't want that, of course, to happen. Now there are two different types. Let's talk about DHCP spoofing. There's DHCP spoofing and there's DHCP starvation. So we got to make sure, but that could happen on the switch itself. So, for example, DHCP spoofing is you get a fake DHCP server, you place it in the network. So when somebody comes in and asks for an IP address, the fake DHCP server gives them IP addresses which really don't belong, is not the correct IP addresses, and those IP addresses may route you somewhere else, right? So that's really a spoofing address. Starvation means when you attack the DHCP server, you'll say, hey, we don't have any IP addresses for you. So sorry, no IP addresses, or does not give you a correct IP address to communicate with the network. Okay, so we got to eliminate that rogue DHCP server. So let's say here's a DHCP server which is closer to the client than the actual DHCP server, which is somewhere else. So when he sends out that DHCP discover, this guy responds first. And if he and the client doesn't know you, so he'll say, hey, give me an IP address. He may give you a bogus IP address, that's spoofing, or tells you, here, sorry, we don't have any IP addresses and you're no good. So this guy will never be able to communicate, right? We got to make sure that this guy does not belong here. So to solve this problem, here's what we're going to do. Well, before we get to that, let's talk about the Cisco Discovery Protocol, the CDP. The CDP is a couple of commands that you could use that you can go out and find out who your neighbors are in terms of IP addresses, if they are switches or routers, and so on. There's a whole bunch of information that can be gathered using the CDP command. Now, if you're not going to use that CDP command, please disable it. Okay, we'll talk about that, by typing no CDP input, and therefore you will no CDP, I think, on the interface. Well, I'm not sure what you could do the question mark to figure it out. I don't want to tell you something that I am not certain of. But you should able to disable. You should always disable the CDP because we hardly ever use it, even for troubleshooting. Anyway, now also leveraging Telnet, like we said before, somebody can always use Telnet to get the password or guess your password, because Telnet uses clear text. As if you have a protocol analyzer, you can actually see it. And they may use it to do denial of service attacks. Keep telnetting and keep guessing the password using a brute force. No one will be able to communicate with the remote device because the remote device is always trying to authenticate that user. And it gets very, very busy. So you always should use SSH, right? That's the best way to really mitigate against telnet attacks. The best 10 practices when you are in an IT environment. Develop a written security policy for the organization. That's really crucial. You have to be able to say what you can and cannot do, what's acceptable for users to do, and what's unacceptable, and what the consequences are. Everything has to be written down. You have to go over that with the user so they understand the policy and what it entails. All right. all the interfaces on the switches that are not being used or on the routers should be turned off. It should be in shutdown modes if you are not using them. Never open one. Use a strong passwords. The 8 characters long, at minimum 8 character long. Also, you should use capital letters, lowercase letters, and symbols if you can. All right, so we'll be able to set that for routers too. Control the physical access to the devices. Your network room should be in a place where no one should have access to it except you. All right, there's physical access, but you got to make sure that you have monitors in there to monitor temperatures and airflow and things like that. In case there's fires, should be alarms in there as well. Always use as HTTPS, the secured, the encrypted tunneled one instead of the HTTP when you are communicating, because HTTP, again, clear text, just like Telnet. HTTPS secures that. All right. Perform backups as much as you can, and make sure you know how to restore, because I know a lot of people that know how to do backup, but when it comes to restoring, they never done it before. And then that's a big problem, because the whole idea of backing up is to be able to restore the data as quickly as possible when there's an issue, right? Educate your employees about social engineering attacks. Somebody sending you an email requesting passwords or requesting money from you, or identity theft. How many times, I've got plenty of those. So, and the only way to really mitigate against these kind of attacks is to let people know there are people out there that they want to gather information from you, and you have to be aware and be very careful to any email that you get. Encrypt all passwords. That's very important, and change them as often as possible, every 3 months. Because if you don't change them, eventually if somebody wants to get in, you giving that person enough time to guess your password, right? Put firewalls in front of your LAN, on the network, and on your hosts as well. And make sure you harden your devices. Hardening your devices mean keeping the software up to date with patches, service packs, and all of that. Download them and implement them and install them immediately, right? All right, so network security tools, there's plenty of them out there, and you should be aware. We will discuss more of that in network security and also when we get into the routers. All right, auditing is important. Every once in a while, you should go and take a look at what's going on. Check out the switches, make sure that the configuration and all the passwords are correct. Check out the logbook to see, if you created a baseline. Check out the IBSs, the intruder prevention systems, if there's any alarms or any red flags that you should watch out for, any misbehaving PCs. Check out for viruses. You have to audit. If you're giving out the PCs or laptops to your employees, you tell your employees, listen, every 3 months, we're going to audit and make sure that you are adhering to the security policy. For example, you're not allowed to download and install software or something like that. By the way, by just telling the employees that they are going to be audited, I found that most people don't even bother installing anything on their PCs because they know they are going to get caught within 3 months. So why even bother? That solves the problem, even if you don't audit. All right, so here's how you can secure unused ports. Just go and type show run. Make sure every interface that's not being used has a shutdown on it, right? Just type the word shutdown. All right, to mitigate against DHCP snooping. So what you do is you're going to say, all right, we are going to make some trusted ports and untrusted ports. So untrusted ports, trusted ports, just like this PC and this PC is going to be trusted. So what you're going to say is DHCP Snooping allow the configuration of all the ports to be trusted on trusted ports. That means you can send DHCP requests. Untrusted, you cannot send DHCP requests on them. So if you are untrusted, you can only send requests. You are not allowed to send. I'm sorry, he's going to send you the request. These are allowed. Only DHCP information could be coming from this port and this port. The switches will allow DHCP requests to come through this port and that port. When you make this FO2 untrusted, that means if this is a rogue DHCP and he sends it, hey, I'm a DHCP, they say, this port is not allowed, and the switch will not allow any DHCP information to be passed between you and the client. So how do you make ports that are untrusted? You type DHCP snooping, and then when you type IP DHCP snooping VLAN 10 and VLAN 20, for VLAN and VLAN 20, go to fast Ethernet 01 and say IP DHCP spoofing trust. So 01 on switch 1 is going to be a trusted port. Okay? And then you go 02 and you type the same thing, and he is also going to be IP DHCP limit, the rate is 5. So on 02, that's going to be the DHCP 5. 5 times he's going to be able to ask for IP addresses. So if this is the trusted port, he is the only one that is going to be allowing IP addresses to go in there. Okay? So he's going to be able to, data can go in and out, and these will be untrusted. Okay? Maybe we'll take a look at that also in class. Now, the best thing to do is to make sure that you can also set up security on the ports. For example, if you have a PC coming into the switch, you can tell the PC, listen, only this PC should be allowed to the switch. If somebody else try to come in, please take them out, right? So you can actually set up security on the port as static, dynamic, or sticky. Sticky is the best way to do it because it's the easiest way to configure it. You don't have static. That means you're going to have to go to the switch and type in the MAC addresses that are allowed to go through the switch. Dynamic, have the switch learn them, but it doesn't keep them, right? Just for a certain amount of time. But the sticky, what it does is just like static, but you don't have to go and type them. He learned them and he's going to make them static, and that's what we're going to do. Okay. What happened if you told the switch only a certain MAC address should come in through the port? And what happened if there's a violation? You can go into protect, restrict, or shut down. We'll explain that as we go along. In fact, let's go back to Packet Tracer. All right, so we're back to Packet Tracer, and now we're going to learn on how to secure a switch. You know what? Let's bring in 2 PCs. We'll leave it in VLAN 1. Well, you know what? Let's have PC 1. He's already in there, right? He's in VLAN 99, and PC 3 is in VLAN 99, right? So here's what we're going to do. You can go, let's SSH into the switch. In fact, let's SSH from here. All right, so let's type SSH and type minus the letter L space. The username that I typed in there was admin, and the password was Cisco. And somehow we are not getting in. Okay, I'm not gonna even, no, it doesn't look like it's allowing me. Did I spell it? Or is it? No, it's not spelled right. It's spelled Cisco wrong. Jeez. Is that right? Let me see. I can't see with my glasses. New PC 1. And let me Hello? Can you hear me? I think we ran into a little bit of a problem, so I hope that that is not a big deal. So the recording is still going. Okay, so let's continue. Okay, just give me a second. I want to make sure that we are still on our way. Okay, yeah, we are still communicating. All right, good. So hopefully that did not cause major problem. Let's go back to PC1, and I want to SSH into PC1. All right, and the password is Cisco. And then I type EN, and the password is Cisco1. Okay. So what I'm going to do is I'm going to say to the PC is config T. Okay. And I'm going to go to interface fast Ethernet 0/3 because I'm going to put another PC right here, right? And I'm going to get, well, actually not 0/3. Let's say 0/1. And I'm going to say switch port mode access. We're already accessing it, right? I'm going to activate the security on it. So I type switch port dash security. Okay, that activates port security. And well, I don't know if that helps. Does that help? Oh, no, I got to see it. Now, once port security is active, hit the upper arrow key and you can say, I want a maximum of 1. So that means you're telling this port only one device can go in. This guy, when he sends a ping to PC3, I'm going to learn his MAC address, and he's the only one that's going to be allowed to come in from now on. If you put 2, that means 2 guys will be learned. Okay, now, then you say, hit the upper key again, say twice, and then say, I want the MAC-ADD to be sticky. So once you learn that MAC address, please remember it. So from that, make it static, and so that from now on, only me, once you learn the IP address, only allow me to come in. Now, what do you do if somebody else comes in? You hit the upper arrow key twice, 3 times this time, and say that violation should be shut down. In other words, shut down the interface if there is a problem. Okay, now what that means is though there are 3 different choices if there's violations. You don't have to shut the interface down. First violation, it could be protect. And well, here they are. I think we went over it right here. Protect, restrict, or shut down. Protect means when you sense an intruder that gets the comes in with a different MAC address, don't shut down the interface. Just don't allow them in, but leave the interface open. That's what protect means. Restrict, do exactly what protect does. Don't allow the intruder in, but also write that down, that when it happened. Shut down, what you do, as soon as you sense an intruder, shut down the interface regardless. And that's the best way to do it, by the way, is shutting down the interface. Okay, so let's go and also let's do the same thing for port. What this is, I think it's on port 2. This interface right here. Yes, it is. It's on port 2. So let's go and secure port 2 as well. I'm going to go to interface fast Ethernet 0/2 and say switch port mode access. Switch port access to VLAN 99. I think we're going to make sure that he's in VLAN 99. And then we're going to say switch port security. Hit the upper arrow key, say a maximum of 1. Hit the arrow key twice, say that they want the MAC add to be sticky. Okay, and hit the upper arrow key twice and say if there is a violation, make sure you shut down the interface. Okay. All right, now do Control Z. Now that the ports are secured, I want you to type show MAC address table. And we see that on VLAN 99 has this IP address and is on 01, right? The VLAN 99. So now let me ping PC1 to PC3. So I go to type exit first, exit, type exit again. Now I'm in a PC. Let me ping 192.168.10.3, which is the PC. Okay. Now I go SSH in again, -L, admin, and the password is Cisco. I'm sorry, we got to type in the IP address of the switch, which is 10.2. And now I lost connection and I cannot get in. 192.168L. Okay, we lost connection. Once you lose connection, you can't do it again. Wow. It's only a one-time deal. All right, you know what we'll do? I'll go to the switch. I want to just show you a couple of things. Type EN. It's Cisco 1. Cisco, actually. Cisco 1. Now type show MAC add. And here is on VLAN 99, I have 01 and 02. This is the MAC address of PC1, and this is the MAC address of PC2, right? Now, let me bring an intruder in. Let me bring an intruder, and he's going to take out PC1. So an intruder comes in, and here, another PC comes in here, PC4, and he connects himself to 01, right? And then as soon as you go in there and you're trying to give yourself an IP address that PC1 had, which is 192.168.10.1. Remember that? Watch what happens. He goes in there, he's connected to PC1, and now he wants to wait till it turns green. We gotta wait till it turns green. Now if I type ping, packet tracer's not working with me tonight. I don't know why. .3. Now it's supposed to shut down the interface. It's not pinging. Now if I go to the switch and show the MAC address table, it still says static. Which port is this at? Port 01, and this is FA00. So if I go in and type show run, and here's the MAC address, 1AD, 4 ADs. Let me type the IP config on this guy, IP config/all, and it's 1AD. Now, okay, now let's assume that this is the intruder, PC1, because we didn't wait till it turned green. So I take this port and go right here and connect. Now he is supposed to be, it's supposed to shut down the interface when you try to get in, because now you got a different PC coming into the LAN. And let's see what happens. By the way, we're going to learn why this is turning amber. It's really because of the STP that it's running. It's trying to blocking the port. Now it's not working. For some strange reason, it is not working. So if I try to bring PC3, bingo. He's an intruder. The interface shut down. Okay, so once the interface shut down, the only way to unshut it because of security is you go to config T, and then you type interface fast Ethernet 0/1. You have to type the word shut down. Now shut it yourself, and then you type no shut to reactivate it. That's the only way to fix an interface that's been shut down. Okay? All right, so make sure you submit this when we are done with all of this work. I know it's a little bit of a mess, unfortunately, but well, we did a little bit of troubleshooting, so it's not that bad. By the way, these are the defaults when you are enabling a security on a switch. We'll practice all of this also in class, so not to worry. Okay, so when you go to an interface, you say switch port mode access, you change it from dynamic to access, and that's the only way to enable port security. It has to be in access mode first. And once you do that, you can actually set the maximum of how many PCs can come in before the violation kicks in and do it sticky, right? So you can actually type show port security interface on 019 and it's going to tell you all the ports if it's been sticky or not. So there's only one guy that came in and he's the address that I learned. And I'll keep that in mind so in case he needs to come in again. Okay, and here's another one. You can use show run begin with fast Ethernet 019. That also shows if it's sticky or not. Show port security addresses. That also tells you there's a sticky port right here, secured ones. All right. Ports in an area disabled. Once you are disabled, if there is your interface shuts down, it's really disabled, not necessarily shut down. So what do? You go into that interface, you type the command shut down, and then you bring it back up. Then you type no shut, right? This is just to show you that there's an error and the interface has been shut down because there was an intruder probably. All right, so you type shut down and then you type no shut to enable an interface that's been disabled because of an intruder, right? The last thing that we're going to cover is the network time protocol, NTP. NTP is really designed to synchronize the clocks of the computer system data network so everybody has the same time. All right. So you should have a server and everybody should be a client that goes to that server and get that time from that server. All right. And here's how you can do it. You can set up R1 as the server, NTP server, and R2 will be the client. So you go to R2 and you say, you don't even have to do anything to R1. You say to R2, NTP master 1, NTP server is 10.11.11. So that means you go get and set up your system clock according to whatever R1 has. And that's it. And you can double check that and make sure that you have been associated with 10.11 and check out your status. Okay? Those are really the only two commands. Again, we'll talk more about this in network security course in details. All right. Hopefully, this chapter is okay. But again, we are going to solidify all of these commands that we did when we go into class. We're going to do it again. We're going to do a little project together, and then we'll implement that on the physical switches when you come to class. In the meantime, read your book, and please make sure that you submit that packet tracer as homework. All right? So until we meet again for chapter 3, don't forget also, by the way, that you do get to the, what do you call it? Week 1, chapter 1, keep saying week 1. Chapter 1, right? You want to make sure that you submit the questions that I asked you, write those in Microsoft Word along with this packet tracer that we did. All right, so until next week, until chapter 3, God bless.